Hello everyone, welcome to the second lecture of this module 11 where we are discussing about smart building sensors. In the previous class, we have talked about radio based technologies used for occupancy detection inside a building, and we have seen that the radio based technologies are of different type, including radio frequency identification, which is RFID, and we have seen that these are basically tag based sensors. Then we have also talked like we can use Wi-Fi, Bluetooth, GPS and UWB, which is ultra wideband signals, to detect the occupancy inside a building. So in today's class, we will keep our discussion alive and we will discuss this radio based technology further. If you remember, we have talked about the RFID sensor in our previous class, where we talked that these RFID sensors can be used for measuring the distance and the proximity of the occupant in the built ambient, right? So today we are going to talk about other radio based technologies like Wi-Fi, Bluetooth, GPS and UWB. Let us talk about Wi-Fi and Bluetooth based occupancy sensors first. So we know that Wi-Fi uses radio frequencies, and common frequency that it uses are 2.4 gigahertz and 5 gigahertz to transmit data between your device, maybe your personal computer or maybe your mobile phone, between these personal devices and the wireless router. Okay, these frequencies are further divided into different channels to help reduce interference and manage many devices at once. Okay, otherwise it can interfere with other, say, Bluetooth and other signals. Okay, of course we use hopping and other technology in Bluetooth to avoid any kind of interferences with Wi-Fi. Okay, so Bluetooth is another wireless technology that enable devices like phones, laptops, even headphones, earbuds to connect and exchange information over a short distance without needing any cables. Okay, it works by using short range radio waves in the 2.4 gigahertz frequency band. If you talk specifically, it is about 2.4 gigahertz to 2.4835 gigahertz kind of frequencies, right? Both these kind of devices have short range of wireless sensitivity. Okay, the Wi-Fi access points act as a radar to detect the occupancy presence using the Wi-Fi signal until it get distorted by any other signal or by any other object in its line of sight. Okay, usually its accuracy is in the range of 2 to 10 meter, and it is based on the positioning method. Okay, the Wi-Fi and Bluetooth based occupancy sensor utilizes the presence of Wi-Fi enabled devices like smartphones, laptops with the occupant to estimate the room occupancy. Okay, detection is based on scanning probe request or connections generated by these devices, the personal devices that occupant possess. Okay, the channel state information CSI from the Wi-Fi signals can be analyzed for fine grained detection of particular occupants. Okay, the advantages of this Wi-Fi based occupancy sensors are it uses existing Wi-Fi network. Okay, so you do not need to actually create external or additional hardware for the detection of these occupants. Okay, so you have already the occupants will carry the Wi-Fi enabled devices, and Wi-Fi router is already existing in the smart building. So you don't have to do actually much hardware placements for this kind of measurement. Okay, this enables real time tracking and analysis of the occupancy pattern. Okay, however, there are certain disadvantages also associated with this Wi-Fi based occupancy sensors, like it can only detect occupants who are carrying Wi-Fi enabled devices with Wi-Fi turned on. Okay, consider the case where the occupant is carrying, say, non-Wi-Fi devices like a simple keypad based mobile phones, or he is not carrying any laptop, or even he is carrying a smartphone but his Wi-Fi is turned off. Okay, in those cases it's very difficult to in fact detect or it's impossible to detect the occupant by using this Wi-Fi based technologies. Okay, it may miss individuals who do not use such devices or or keep Wi-Fi disabled, right? So for the alternative technology, you have a Bluetooth based occupancy sensor. Again, it also uses the low frequencies, the frequencies of order of 2.4 gigahertz or so. Okay, the Bluetooth low energy profile, the BLE profile, is used as a low power solution for control and monitoring applications. That is, it can be for security application, or it can be just for monitoring the occupants. Okay, the proximity Bluetooth low energy devices is used for gathering the occupancy location and the distance information. Okay. The advantage of this Bluetooth based occupancy sensors are, as the name suggests, they are low power consumption devices. So they are ideal for battery powered sensor, although it is not battery less, but it is very low power devices. Okay. Then it is effective for real time proximity based tracking and personalized user experience, because each occupant will carry the Bluetooth enabled device. Okay. Of course, the basis of this Bluetooth based occupancy sensor is like that. Okay. And then there are certain limitations also associated with this Bluetooth based occupancy sensor, like occupants must have a Bluetooth based device or Bluetooth enabled device and leave the Bluetooth always turned on. If the Bluetooth is not there in the device or it is not turned on, similar to the Wi-Fi based occupancy sensor, it will simply not work. Okay. Then beacon range is typically shorter than Wi-Fi, requiring a strategic placement for larger areas. Okay. Then alternating technology for this Wi-Fi and Bluetooth based devices are UWB based occupancy sensor or ultra wideband based occupancy sensor. So let us see what is the transmission method in UWB based occupancy sensor. The ultra wideband UWB is a wireless communication system which emits very short pulses of radio wave across a broad frequency spectrum. Why I am saying the broad frequency spectrum? Because we have seen that for Wi-Fi and Bluetooth, the spectrum is not that wide. However, here the spectrum is really huge. It's from around 3.1 gigahertz to around 10.6 gigahertz. Okay, and that's why I have mentioned that across a broad frequency spectrum. Okay. Then this is the transmission method. You usually emit very short pulses of these UWB waves. Okay. Then the system estimates the distance to occupants or the object by measuring the time taken by these pulses to travel to and fro from the sensor. Okay. This process delivers centimeter level accuracy for localization. Okay. So you have a very accurate measurement with this UWB based devices. In fact, the accuracy of the occupant position sensor is of the order of 10 centimeter to 50 centimeter or so. Okay. Then these UWB sensors can detect not only the body which is in motion, but it can also detect objects which are in a stationary position in a smart building. Okay. So it can distinguish basically between a human or object by analyzing the reflected UWB pulses. Okay. Of course, it doesn't has to do anything with the lighting or obstructions in its path. Okay. So these measurements can be done in harsh conditions also. The obstructions I want to say means the cloths, the glasses or plastic wares inside the building. Okay. So it carries, of course, lot of advantages associated with it. Okay, like UWB can localize occupants with an accuracy better than 30 centimeter. We have just seen that it can go to something in the range of 10 centimeter to 50 centimeter. Okay, the sensors can operate with minimal energy consumption, enabling battery powered deployment that lasts for years, because you are using anyway in the pulse mode, so you do not have to continuous emit UWB, right? So by that actually you are saving lot of powers. Okay, and that's why the claims are that these devices can work for even years without the replacement of batteries. Okay, UWB relies on anonymous radio detection. It avoids privacy issues associated with the cameras, which still provide real time presence and movement data. Of course, it can be compared with the camera based system, which are very much reliable, okay, but of course the time of line of sight and other things were a problem. Here those problems are also sorted out, okay. Then UWB is effective even in a complex environments with barriers or dense clutters, and has minimal interferences with other wireless technology. We have seen that other wireless technologies that are used in a smart building do not use the frequencies that I am using in the for the UWB pulses, okay. So it has minimal interference, or in fact there is no interferences for the occupancy detection for this kind of devices, okay. These devices detect the presence or absence of people in a very fast manner, okay. These devices are actually very fast, okay. Therefore these are suitable for critical automations like for lighting, for HVAC control, as well as for security control, okay. And we have seen that the accuracy is also of very decent level. That's why these devices can be easily applied for this kind of application, okay. Then UWB sensors are typically small and can be mounted behind non-metallic surfaces also. So it will ensure a flexible design of these sensors, okay. However, these sensors has also certain limitations, like UWB technology usually involve higher hardware and installation costs compared to the alternating technologies like Wi-Fi or Bluetooth, because there actually you are not utilizing any external hardware. What you are relying upon is the devices that the occupants are carrying, or the Wi-Fi routers which are placed inside a smart building. But for UWB technology, if you want to use it, you have to actually arrange for the hardwares for the better operation of these devices, okay. Although the UWB is robust, very dense barriers or reflective surfaces can occasionally affect the performances, but not always, okay. The UWB's precision tracking abilities require careful adherence to privacy laws and strong anonymization for different protocols, okay. The integration with a building automation system and IoT platforms is essential to leverage the full potential of UWB sensing. However, this kind of integration is not easy because the wavelength that you are using here is a odd wavelength, and none of your systems are utilizing it, okay. So you have to integrate it with the existing BMS system very carefully, okay. Then another kind of device that we thought that we will discuss or we will utilize is the GPS or the global positioning system. How we can use a GPS system to basically, this is mostly localized to outdoors, but of course you can still use it in the indoor ambience also, okay. So the GPS is used for the occupant detection and monitoring in the built environment, okay. To detect the occupant position, the occupants need to carry a GPS enabled devices, very similar to the Wi-Fi based devices and as well as the Bluetooth based devices, okay. So of course if he is carrying GPS, of course it has to be enabled also, okay. Usually in a smartphone nowadays, all smartphone nowadays carry GPS systems, but then there are other wearable devices like in the form of smart watches, smart rings. These GPS systems can be integrated, and of course it is existing in the market, okay. So the occupant, if he is carrying this kind of smartphones or this smart wearable devices like smart rings or smart watches, this you can rely upon this GPS system. Let us see quickly how this GPS based occupancy sensors, okay. So GPS technology provide geolocation data using signals from the satellites, okay. Occupancy sensing with GPS services involve monitoring the real-time locations of the occupant via smartphones or wearable devices with GPS. Now the GPS data can be linked to a smart building management system to infer presence, activating security, lighting, or HVAC based or whether authorized devices are within building boundaries, okay. all these functions can be done once you are able to get signal from the wearable GPS devices. Okay. So these are mostly the radio based devices, and they are in the modern smart buildings. These devices are, or these methods of monitoring occupancy is very common, particularly in a crowded mall, okay, where the BMS team can sense that if the Wi-Fi signal, I mean if the number of Wi-Fi occupancy in the area is increasing, they will definitely sense that, okay, today the mall is going to be crowded. Okay. Similarly for Bluetooth based devices and these GPS based devices. Okay. Similarly for the outdoor ambient also, this GPS device can work for tracking the occupants. Okay. Then since we are discussing the smart building sensors, we will keep our discussion to the smart buildings only. Okay. The next kind of devices which are used or very much utilized for monitoring the occupancy in a building is a threshold and mechanical sensors. Threshold and mechanical sensors detect the occupancy or the occupant presence in the building when they interact with something. Okay. This something can be the windows or the doors of any room or main gate or anything with which occupant can interact in the building. Okay. There are different threshold and mechanical sensors in a smart building, and some of them are like read contacts, door badges, piezoelectric mats and IR beams. Let us quickly see these 4 different kinds of threshold and mechanical sensors before we actually go to environment sensors for a smart building, which is equally suitable or equally helpful in analyzing smart building. Okay. So our next discussion will be on environment sensors inside a sensors building, because it actually define or it actually decide the health condition of an occupant. Okay. So let us but first finish this threshold and mechanical sensors. Let us talk about read contact based sensor first. Okay. The read contacts are used to detect occupant when a door or windows is open or closed. Okay. These devices are magnetic devices and low cost devices and consume very low amount of energy for their operations. Okay. A read contact sensor, as I have mentioned that these are magnetic sensors, they consist of 2 ferromagnetic and flexible metal reeds which is sealed hermetically inside a glass tube. Okay. When a magnetic field is brought near to the sensor, the reed moves together. Either it is completing a electrical circuit or it will break a electrical circuit. Mostly it breaks, but then you can have read contacts or read switches where it actually complete the electrical circuit. Okay. So when the magnetic field was not there, the circuit was incomplete. When it is there, the circuit is complete, and by this you can have data in the binary form, means the door is either closed or door is either open, or the occupant is present, either occupant is present or occupant is not present. Okay. So this simple reliable design allows for precise detection of physical events, for example the opening or closing of doors and the windows. Okay. Now there are various advantages associated with this small and simple magnetic read contact sensors, like they are as I have mentioned, they are very simple, however they are very reliable technology. Okay. They are low cost devices and can be easily installed. Okay. They do not need actually a complex calibration. Okay. A simple calibration can help them to operate. Okay. Then there are certain limitations also associated with these read contact sensors, like they cannot detect individual presence. Okay. It can only tell about the door status. If the door is getting opened, it means that you have to assume that it is opened by a certain occupant. Okay. Then in such a scenario, it becomes very difficult to actually monitor the multiple entry or the tailgating. Okay, so it may not account for multiple entries or exits without additional logic, particularly in the condition of tailgating. Okay, and it works best in area with single access doors. Okay, if you have multiple access doors, then you have to have an additional level of logics to sum them, or for additional data. Okay, then you have door badges as a mechanical and threshold based occupancy sensor. Door badges are sensors which require occupants to swipe to access the building's interior. Okay, this helps to count the occupants, but if more than one occupant passes through a single swipe, the device doesn't count the number of occupant passing correctly. Okay, because it counts only the number of swipe. Again, the problem is the tailgating. Okay, so if certain level of tailgating is happening, it's very difficult to capture that using these door badges. Okay, so these are commonly basically card or RFID badge, okay, which detects occupancy in a smart building. Okay, by monitoring access events when people uses their badge to enter or to exit a particular space. Okay, so how these devices operate, like when an individual uses their badge at a sensor enabled door, which is basically a reader. Okay, the system log the event including the identity, time and direction. When I say direction, means as I have mentioned, it's a binary device. So direction means it either the occupant is entering the building or he is coming out of the building. Okay, so these systems can provide live metrics on room or particular area usage. Okay, the advantage of this door badge sensors are their accuracy. So they can track specific user movements, tying the occupancy to actual authorized personnel. Okay, then they can easily sync with the building management and access control system for automation. So its integration with the BMS system is very easy. Okay, then it generates historical and real-time occupancy reports for resource allocation and space planning. So analyzing this data is very effective. Okay. However, there are certain limitations also associated with this door badge sensors, like it requires compliance. So accurate detection assumes users always badge in and out. Tailgating or missed badge events can reduce the accuracy. Okay, and the system knows only the entry exit events, not if people remain inside after an event unless integrated with some additional sensor. So means that no passive presence detection is possible using this door badge based sensors. Okay, then third kind of threshold and mechanical sensor is a piezoelectric mat. Okay, piezoelectric mat work when occupant pass or stand on the mat to produce an electrical signal. Of course, these mats are not simple door mats. They are basically flat mats or tiles which are embedded with piezoelectric materials. This can be ceramic or based on polymers. We have seen that in detail in our previous module, like for PVDF and other quartz kind of material, these things are possible. Okay, so when mechanical pressure, for example, by the person's footstep when he is walking, when mechanical pressure is applied, it generates a measurable electric signal, and the signal is processed to detect presence, movement or the foot traffic event, like how many people are coming. Okay, so there are various advantages associated with these piezoelectric mats, like these are battery-less devices, so no external power is required for basic sensing. It has longer lifespan due to lack of moving parts. It can detect minimal pressure changes. Okay, and can be easily integrated with the diverse building infrastructure. Okay, since these are simple piezoelectric material, the cost associated with these mats are also not very high. Okay, However, there are various limitations also associated with this piezoelectric mats, like they are most effective for dynamic pressure like any other piezoelectric device. Okay. However, they are not so good for detecting stationary occupancy. Okay. Then signal processing is very much necessary for accurate measurement, especially with the group of occupant or a heavy traffic of occupant inside a built environment. Okay. It may require multiple sensors for large areas to improve accuracy. Okay. Then finally, we have IR beam based occupancy sensor. Sometimes this IR beam based occupancy sensor is also known as IR break beam sensors. Okay. The IR beam based occupancy sensors function by producing an IR signal, and when the signal become blocked or the signal beam is blocked by the occupant, it count the occupant. Okay. So the IR beam based occupancy sensor or IR break beam sensor composed of a transmitter of infrared light and a receiver to detect the IR beam which is transmitted by the transmitter. Okay. When the beam is interrupted by the occupant, the sensor register an event like in the form of count. Okay. They are used for entry exit monitoring and people counting in real time. Okay. The advantage of this IR break beam sensors are they are cost effective and easy to install and maintain. If you see the system, it carries only a transmitter of IR light and a receiver of IR light. Okay, and what you are measuring it is the events when this beam is broken. Okay, so these devices are cost effective and easy to install and maintain. Okay, they are accurate for monitoring entrance, hallways and controlled access points. System can work in various environment condition and do not actually depend on visual light coming from a simple light bulb in the building. Without that also it can monitor. Okay. And it support privacy, so you are not using actually any camera here to capture images or to store personal data. This can provide you a real time data based on the interaction of the IR light coming from the transmitter and the receiver. Okay. The limitations of these devices are they can only detect movements through the monitored beam, not the static presence in a room. Once the person moves from the line of sight of this IR light, it is very difficult to monitor it. Okay. It cannot distinguish between multiple people crossing simultaneously, so there is a risk of miscounting. Okay. It requires clear line of sight between the transmitter and receiver. Okay. Of course, you can use it in the form of reflections, then you should use array of detector. I mean those scenarios are complicated scenarios. So for the time being we understand it as a line of sight based sensors only. Okay. So it may need careful alignment and mounting for optimal performance. Okay. So these are all about the building or smart building occupancy sensors. Okay. In the next class, we will talk about building environment sensors. This will include temperature and humidity sensors, then air velocity sensors, photometric sensors, gas sensors, for example, a carbon dioxide sensor or a volatile organic compound sensor or any other toxic gas monitors. Okay. Then two important things that we are going to discuss in next couple of lectures are the particulate matter sensors and the smoke detectors. Okay. So we will keep our discussion on the smart building sensors in our next class also. Thank you.